Computer Science Department in Kyung University, South Korea. Previously, he has worked postgraduate fellow in Middlesex University, London. He completed his PhD in Bellew Institute of Technology, University, and his current interests include big data analytics, and Internet of Vehicles in healthcare. He is an associate editor for International Journal of Wireless Networks and Broadband Technologies (IGI). He is also a technical committee member for computer communications elsewhere. He has edited many special issues as a guest editor for reputed publishers like Elsewhere, Wiley, Springer, etc. And he also acted as author and co-author for several international journals and conferences, including STI Index. He has published papers in which 3 are in IEEE Access, 5 in IEEE Transactions, 2 in ACM Transaction, 9 in Elsewhere, and 16 in Springer publications. He is a reviewer for Elsewhere, IEEE Access, IEEE Transactions, and Springer Journal. He is a lifetime member in International Society for Infectious Disease, Computer Society of India, and member in Bellew Institute of Technology Alumni Association. We are very thankful to you, sir, for accepting our request and adjusting your schedule for taking a session in a workshop. And today's topic is IoT and applications.
Hi, thanks for the brief description about me. And today I'm going to discuss with you all about Internet of Things with applications. And it is a most important topic right now. And most people are already have aware of that. And most people are already doing research in these areas, Internet of Things and Internet of Medical Things, federated learning with analytics and big data analytics area domain. So thanks for Professor Aziz to inviting me in this faculty development programming. And let me enter into our section. And if you have any queries, please note down and you can ask at any time. So these are the outlines we are going to see about the introduction of IoT and its definition, motivations of IoT, and IoT and its key features, and IoT architectures, and stages of IoT and its architecturals, and the pillars of IoT. And finally, the main thing is IoT with applications. IoT with application, if you're all aware of the applications, it is related to home appliance and medical data, as well as Internet of Vehicle Things and the Internet of Medical Things. So, and also IoT is now everywhere throughout the world. In our day-to-day life, people are using those sensors, in different kind of sensors in our day-to-day activities. For an example, people are calculating our steps with the help of motion sensor. So, and also with the help of the walking distance and the help of the heart rate, we can easily manage our health data. So here, the Internet of Medical Things play a major role in that one. Internet of Things. IoT describes the networks of physical objects, things, and embedded things, which are easily synced to any other data and which gives the true information about the data. And this is the definitions. These are the given definitions. And the Internet of Things, also called the Internet of Objects, refer to a wireless networks between objects. Usually the network will be wireless and self-configuring such as household applications. Through the Wikipedia, we have searched. And the recent definition is things having identities and virtual personalities operating in small spaces using intelligence interfaces to connect and communicate within social, environmental, and user conduct. So, and these are the motivations of IoT. IoT system allows users to achieve deeper automation, analysis, and integration within the system, which approves or which improves the reach of these areas and their accuracies. So, Internet of Things utilizes existing and emerging technologies for sensing, networking, and robotics. So it can be used in various platforms and various domains. We can use as what we need. We can easily use that data. So for my example, I have used healthcare data. So for that purpose, I have used most number of sensors like wearable sensors, like gyroscope sensors. So those types of sensors I have used. So it depends on the person to person and person to research. And IoT key features. So, sorry, is it audible? Yes, IoT key features. The most important key features for IoT include AI, connectivity, sensors, active engagement. Sorry. Is there any problem with the connectivity? Sorry for the disturbance. And okay, so A is IoT essentially makes virtually anything smart meaning. It enhances every aspect of life with the power of data collections and artificial intelligence algorithm and networks. So this can mean something as simple as enhancing your refrigerator and cabinets to detect when milk and your favorite cereal run low. So that's how our AI will give you valuable assets and connectivity. So the new enabling technologies of networking and specifically IoT networking means networks are no longer exclusive tied to major providers. So networks can exist on a much smaller and cheaper scale while still being practical. IoT creates these small networks between its system devices. So it continues the sensors. IoT loses its distinct without sensors. They act as defining instrument which transform IoT from a standard passive network of devices into an active system capable of real world integration. So active engagement. Much of today interaction with connected technology happens through passive engagement. IoT introductions, a new paradigm for active content, product or service engagements. So for small devices as predicted have become smaller, cheaper, and more powerful. So over time, IoT exploits purpose-built small devices to deliver its precision, scalability, and versatility. Sorry. Yes, the IoT architecture. There is not such a unique or standard consensus of the Internet of Things architecture, which is universally defined. So the IoT architecture differs from the functional area and their solution. However, the IoT architecture technology mainly consists of four major components. The first one is sensor or devices, gateway and networks, cloud or management service layer, and the final one is application layer. So these four components are the major components for the IoT architecture: sensor and actuators, devices, and gateway, cloud. So we will see one by one. First one is the sensor. Sensor are actuators or the device that are able to emit, accept, or process data over the network. So these sensor or actuators may be connected either through wired or wireless mode. So this contains GPS, electrochemical, gyroscope, RFID, etc. So there are n number of sensors. Most probably you people are aware of that. Gyroscope sensors. It is particularly used for the healthcare monitoring. And take a scenario, if you're monitoring a patient for 24 by 7, so you have to fix the wearable sensor in the patient body. So automatically it will calculate the each and every data of the patient, and it will monitoring the patient 24 by 7. So if there is some attacks or some interrupts happen, or something happen to the particular patient, automatically it will send an alert message to the particular physician or the nearest number. So that's how our sensors will play a major role in the healthcare domain. And we have carried out large number of health clinical data. So if suppose any intruder can easily hack our system, can easily manipulate the data, it will create a major problem for the handling healthcare data. So for that purpose, we have to add more security features and while handling the data in the research aspects. So gateways and data acquisition. So as the large number of data are produced by this sensor and actuators need the high-speed gateways and networks to transfer the data. So this network can be of the type of local area network, such as Wi-Fi, Ethernet, or etc., and wide area network, such as GSM, 5G, now 6G is enabled here. So there is a number of network areas. And Edge IT, Edge in the IoT architecture is the hardware and software gateways that analyzes and pre-process the data before transferring it to the cloud. So if the data read from the sensor and the gateways are not changed from its previous reading value, then it does not transfer over the cloud. So this saves the data used. And the data center, this is the final one. And this is how the stages will be divided. And the data center or cloud comes under the management service, which process the information through analytics and management of devices and security controls. So besides these security controls and device management, the cloud transfer the data to the end users applications such as retail, healthcare, emergency environment, and energy, etc. So for an example, if you're handling the healthcare data, so for that purpose, Kujo simulator will play a major role. So if you are running your data modeling, or if you are running your algorithm, if you are running the concepts, you can easily adapt your techniques into the Kujo simulator. Kujo simulator is particularly used for the purpose of IoT security. So if you're working in IoT area, obviously you have to work on the Kuja simulator. You have to know about Kuja simulation. So it will help you in your research output. So these four pillars of the IoT, SCADA, machine-to-machine, RFID, and wireless sensor network. So these four will play a major role in IoT and IoT applications. So these are the top 10 IoT applications currently working in that. And the first one is manufacturing or industrial. It consists nearly 22% of the IoT users which is using the same platform. And the second one is transportation or mobility. And the third one is energy, retail, cities, healthcare. So IoT in every domain. Like IoT will play a major role in smart cities. For an example, it will reduce the traffic. Traffic congestion, as well as it will easily calculate the data. So based on the history of the traffic congestion, automatically it will create a best output. As well as in healthcare domain, it will create a major impact in with the help of wearable sensors. And in the retail, also each and every devices will have the barcode or RFID tag, so we can easily monitor each and every packet of retail shops. So in each and every domain, it will play a major role. So we will see one by one in the upcoming slides. So first one is manufacturing or industrial. The overview is it has taken over the top spot from cities, the number one IoT application areas in the 2018 analysis. So technology gains such as Microsoft and AWS, as well as large industrial automation players such as Siemens or Rockwell Automations are among the driving forces of the digital transformation in the manufacturing or industrial things. So industrial IoT is transforming the rules of manufacturing, fueling cloud and edge innovations, accelerating the evolutions of digital factories and enhancing the operational performance. So this was told by Satya Nadella. You all are aware of that Satya Nadella. He is CEO of Microsoft. So, and the industrial IoT applications area covers a wide range of connected things, projects, both inside and outside the factory. So for an example, inside many IoT based factory automation and control projects include holistic smart factory solutions with numerous elements such as production flooring monitoring and wearables and augmented reality on the shop floor, remote PLC control or automated quality control system. So typical outside the factory projects include remote control of connected machinery, equipment monitoring or management and control of the entire remote industrial operations such as oil rigs. So many of the case studies mention reducing operational downtime and cost saving. So these are the key drivers for OEM to introduce industrial IoT solution. So with the help of that IoT only, it has been implemented. So for the example, Severustal asset performance. So Severustal, a Russian steel manufacturer, turned to G to reduce unscheduled maintenance delays with predicts asset performance management. So the solution enhances the equipment reliability by 20% by means of constantly improving strategies of maintaining, reducing the cost of repair and maintenance scheduling, effectively relocating resources and decreasing the production risk. So next word is transportation or mobility area. In transportation is the second largest IoT application area. So Tesla set the industrial benchmark for a connected cars when it launched the Mobile S in 2012. It introducing the first over the air software update capabilities. Since then, pretty much every car manufacturer has followed the same protocol. Obviously, you all are well aware of that Tesla. Tesla is full and automatic car. So there will be the some flighting mode and autopilot mode. So if you have clicked the automatic pilot mode, automatically it will drive you very good and it will reach your home most safer. So recently Tesla will play a major role in industrial domains as well as in transportation domains. So with the help of IoT sensor, for an example, in the moving vehicle, obviously there is a number of sensors they have fixed. So with the help of the sensors only, they can, with the help of the sensors and IoT only, the autopilot mode is available. For an example, if you are going near to the any kind of vehicle within you're reaching the smaller distance like 5 meter or 3 meter, automatically it will voice alert. So obviously you are aware of that. So it is full and fully automation. So Tesla will play a major role in IoT transportation area. And connected solutions bring increased vehicle and construction equipment uptime for our customers, better safety for drivers, operators, and other road users, and of course, less emission of carbon dioxide. The first million connected assets at Volvo is only the start. So we are committed to remain a leader in this field. So this was told by CEO of Volvo company. So the typical application within the transportation or mobility analytics and fleet management solution that connect with the local operating system within the car for vehicle diagnostic or monitoring such as battery monitoring, tire pressure monitoring, driver monitoring, or simply vehicle tracking. So these are the examples for that one. The first one is KWRL real-time fleet monitoring. So KWRL Transportation Corporation runs a large scale of school bus fleet in Washington, USA, and uses Samsara's wireless fleet tracking platform to coordinate routes and keep buses running on schedule. So real-time fleet monitoring supplies visibility into where buses are at any given moment. Sensor track stop pedal and emergency light activation and engine fault code alerts are automatically decoded. So team instantly determines critical of faults and complete route history is used to build smarter routes and plan fleet expansion. So the next example is omnibus fleet operation optimization. So omnibus is the leading long-term bus service in Finland, building a more streamlined and sustainable transport operation with a Telia connected vehicle solution designated to optimize the operation of heavy equipment and reduce the fuel consumption using real-time operating data. So next we are moving into the energy sector and how the energy sector will be dependent on IoT platform. As a worldwide energy consumption is expected to grow by 40% over the next 25 years, the need for smarter energy solution has reached an all-time high. So IoT is a revolutioning nearly every part of the energy industry from generation to transmission to distribution and changing how energy companies and customers interact. Both solution providers and energy companies themselves understand the need for and value for connected IoT solutions in the sector. IoT exists, there is nothing futuristic about it. Already today, advanced sensors make it possible to monitor and communicate grid data. So the information gathered by the sensor is transmitted to gateway and elaborated by data centers using machine learning algorithms with increasingly sophisticated models for data reading. So this process brings enormous benefits in terms of grid efficiency. This was told by Fabio Bernis, head of infrastructure and network digital hub at Enel. So now energy will play a major role in all domains. So how our IoT will give a great output here is there is n number of energy wastage. For an example, in India, there is a number of energy consumption wastages in street lights. For an example, in street lights, if you are fixing the sensor, automatically it will detect the daylight. It will detect the energy consumption and the energy saver mode. So in daytime, the energy saver mode is actively available. So automatically the energy consumption is more while compared to the existing methods. So energy accounts for 11% of the identified projects, up from 10% in 2018. So the majority of the projects focus on energy distribution, grid optimization, remote asset monitoring, and management. So predictive maintenance and creating more transparency for better informed customers. So example here, Exelon Wind Power Forecast Model. So this is an American utility company. So Exelon optimizes wind forecasting accuracy with GE Predicts platforms to achieve a 70% performance increase for their wind farms. So the GE data science team created a visual and statistical wind power forecast model based on the historical data provided by Exelon. So they incorporated diverse data sources and took into account seasonal or time of data effects, ran the analytics in Redix Cloud, and wrote back the results in seconds. So next we move on to the retail area. More and more retailers recognize that they can improve their cost efficiency in store customer experience through innovative IoT use cases. So there is a rising interest for retailers to digitize stores and create smarter processes. Retail now accounts for 9% of the identified projects, so up from 5% in the 2018 analysis. So the potential to gather data and put it to use more effectively is exciting. So we are learning how IoT can help us to work differently. We are improving many of our process, and we are empowering our associates with better tools and technology. So this was told by CEO of Walmart. So typical IoT in retail solutions include in stores digital signature, sorry, and the customer tracking and engagement, goods monitoring and inventory management, and smart vending machines, among others. So each and every aspect, the sensors will play a major role, whether it is RFID or barcode or any particular tag. So it will play a major role in retail areas. So for an example, in new media mixed reality solution, it is a US based new media innovation digital host solution. So powered by Digi is using mixed reality technology that mimics human experience to enhance customer experience. Example, smart digital kiosks have interactive self-services holograms that acts as a virtual sales rep and product specialized on the storefronts lines. So these holograms together with the digital signature project, a company brand personality to attract, automate and analyze customer engagement. I will give you the real-time example. In US, Amazon have opened the full and fully automated retail shop. So there will be no manpower over there. So you have to go directly and you have to purchase the things and you have to build those things. What you have purchased, you have to build those things. So once you have paid the bill, automatically then only it will open your door to come outside. So each and everything over there is full and fully automatic with the help of sensors. For an example, if you are entering into the Amazon store with the help of the sensor only, it will detect your face and it will allow you to access those things. So once you have purchased those things with the help of the bar scanner or the barcode scanner, so with the help of that, you can easily pay the bill. With the help of that, you can easily tag those things, and once you purchase those things, you can pay the things with the help of your card or any other devices. So the Amazon shop is full and fully automated. So most probably this will reach throughout the US in upcoming years. The next thing is cities, IoT with the smart cities. Smart cities are growing and blossoming in all parts of the world. So the percentage of smart city project is down from the 2018 analysis for a number of reasons, such as long tender timelines, long lead time to get smart city project started, and need to navigate city politics. So the CEO of IoT platform, startup for example, recently shared with IoT Analytics that sometimes smart city tenders timelines are so long that startups can't survive long enough to wait for the process to finish. So the process tends to be biased towards the largest vendors. By brief is to rethink the smart city from the ground up, meaning to rethink technology, IoT and data focusing on what it can do serve the people. This was said by Francisco Bria, CTO of Barcelona Smart City Projects. So typically, IoT projects in smart cities include connected traffics, that is smart parking, traffic management, utilities like smart waste, lighting, and public safety. It is like video surveillance and environmental monitoring, air pollution. So these are the selected IoT platform enabled projects for examples. So in Amsterdam Smart LED Lighting Project, Amsterdam Smart Lighting Scheme includes a deployment of 144 LED smart streetlights along with cameras and public Wi-Fi network in a Hukran square. So the LED lights can be controlled remotely and automatically adapt to different lighting conditions. This is what I said previously. So this technology will be implemented in India. There will be loss of energy consumption. So obviously India is a big country, so most probably we have to adopt this kind of technology. Then only we will save most energy consumption, as well as we keep our environment as polluter free as well as. So the Singapore Sensor Data Sharing Platform, Singapore uses an integrated sensor platform, a smart nation sensor platform, to collect, analysis, and share data from connected sensors and devices to improve urban planning, transportation, and public safety in the island. Example of data sources include residential meters, traffic counters, cameras, and lampposts. Today, I have read an article in Singapore has announced they are going to implement another 12 lakhs cameras throughout every street. So to monitor the crime areas. So most probably they are adapting each and every technologies with the help of the sensor only. So they are monitoring the smart cars with the help of the sensor, and they are monitoring the speed. They are calculating the speed of the vehicle with the help of the sensor and how much speed the car has traveled. So each and every role the IoT will play a big impact. And next we move on to the healthcare domain. Uh, Most probably you people are all aware of that internet of medical things. Internet of medical things is the emerging research topic right now. And in Switzerland, Cleveland data sets, you all are aware of that. Most probably if people are working in healthcare domain, they are working with the Cleveland data sets. So there will be only 250 GBs of data. You can't able to run the big data. So if in a real time aspects, the most of the US healthcare managements will comes under the Internet of medical things. So Internet of things has only slowly proliferated itself in healthcare. However, things looks to be changing in light of the center of COVID-19 pandemic. Yearly data suggests that digital health solutions that relate to COVID-19 are surging. Demand for specific IoT health applications such as telehealth consultation, digital diagnostics, remote monitoring, and robot assistance is increasing. There is a huge applicability of technology, data, and communication methodologies to tackle the current pandemic and help improve healthcare solution through telehealth and telemedicine. Demand is emerging across the globe. There is a growing number of patients being remotely treated globally. For example, there are a number of online consults globally has gone up to 50 to 100 times in many health systems already. For an example, in all the European countries, they will give the counseling, medical counseling through the telephone. So you don't want to go directly through there, because if you, only the COVID patients are allowed to contact them directly. So for the rest of the disease, you people have to contact them through the telemedicine. So you have to tell your things with a particular physician or particular doctor. So they will give you the telemedicine. So that's how the environment will working right now. So typical healthcare IoT projects within the hospital clinics includes medical devices monitoring, health team coordination, optimizing workflow, operations, while outpatients focused solution include patient monitoring, assisted living, elderly care, and pain medication management, among others. So these are the examples. The first one is Medicine remote monitoring, remote patient monitoring. So Medicine Day, or simplifying remote patient monitoring with continuous monitoring of assets connected to the healthcare application. So including battery life and general health of the device. So which allows personalized patient care anytime, anywhere, and equip care teams with a near real-time view of the patient health and activities. The next one is Medtronic connected pacemaker. Medtronic offers connected pacemakers, which are small devices implanted in the chest or abdomen to treat patients whose hearts are beating too slowly or irregularly. So the device gathers data such as transmission history, battery information, updates on physical activity, and vital tracking, and can stimulate the heart muscles with the electricity pulses that restore the heartbeat rhythm to a normal state. So next we move to the supply chain application. As supply chain extend more and more to the end user, resulting in more intricate flows of goods that are more complex to deliver, logistic providers are increasingly integrated, connected digital solution to tackle the complexity. A recent survey by Kenco, a US logistic provider, found that 56% of supply chain professionals are currently and planning to invest in IoT sensors. It's up from 42% in 2017. So there is a huge growth in this domain to look for more operational efficiency in how their supply chains operate. So the transformation of AP Moller Mosque from a diversified conglomerate to becoming a focused, integrated, and digitized global logistic company continues. In particular, usage of our digital services has increased significantly over the last year, with more and more customer beginning to explore options for remote management of their supply chains. So this was told by CEO of AP Moller. So the next typical supply chain IoT project include asset tracking, condition monitoring, example cold chain medical goods, inventory or storage management, automated guided vehicle, connected workers, among others. So the COVID-19 pandemic has highlighted the value of the IoT tracking across the supply chain. The recent months have unfortunately shown the stark reality that even vital medical equipment and PPE can go out of the stock as global supply chains are disrupted. So this realization is expected to be a big driver for IoT tracking solution in the supply chain to help companies stay in control, keep an overeye, and react quickly. And example is Rotterdam Connected Port. Rotterdam Port is using sensors throughout their expansive dock facility to continuously gather real-time data about air temperature, wind speed, relative humidity, turbidity, and salinity of the water plus water flow, and levels, tides, and currents. So the port even has digital dolphins, smart QR walls, and sensor-equipped boats. So and is exploring connected container solution to gather the data and use AI to predict more accurately what the best time is to moor and depart cargo ships at port to reduce the waiting time and cost. So next we move to the agriculture application. In 2050, it is estimated that a population of almost 10 billion people will need up to 70% more food than we do today. So one way to address this challenge is through smart agriculture. So with the help of smart agriculture only, we can maintain these ratios. So IoT sensor can help farmers make more informed decision to achieve higher crop yield, better quality produce, and save cost by reducing the use of fertilizer, pesticides. So some CEOs see IoT as the main source of disruption for the agriculture industry. So here we can see one CEO definition how he is handling with IoT. John Deere sees the adoption of information technologies and IoT service in agriculture as no less transformative than the introduction of self-propelled machines to farming a century ago. So we believe that precision agriculture practices in use today are laying the foundation for the future of farming, a continual, smart, evolving, and more efficient farming. This was said by John May. He is the CEO of John Deere. So typical smart agriculture projects include precision farming, livestock monitoring, irrigation management, and automated drones for surveying farms, mapping fieldings, spraying crops, etc. So analysis of the case study suggests that innovative technologies such as LP-WAN are paving the way for smart agriculture growth in the IoT landscape. So LP WAN supplies a range of features in terms of energy consumption on long range transmission. So that is the main network requirements for key application in the sector. LP WAN are ideal for gathering data about local agriculture condition, including weather, soil moisture, and chemical composition of the soil and other environment condition at much lower total cost of ownership. So furthermore, LP WAN make it possible to expand per acre coverage and monitor more assets due to the simplicity of deployment and cost of ownership reduction. So example, QKG connected greenhouse, we get so much insight into the temperature of our peppers during the growth phase and can adjust the greenhouse climate accordingly. So based on this information, we can continually improve the quality of our produce while cutting energy cost. This was said by Sander Burgers. He is a supervisor at QKG Moos Pepper Farm, Netherlands. So this is a real-time example he is given. And next sector is buildings with IoT. As part of 2019 energy efficiency indicator study, Johnson Controls surveyed 400 energy and facility management executives in the US and found that 71% of the organization invested in smart building control system improvements, and over half have implemented an enterprise-wide smart building management system. Most new innovative connected solutions aim to increase productivity and efficiency while reducing the operational cost through complete building lifecycle management. So buildings have been there for thousands of years, but unaware if someone were to enter or leave them. With digitalization and IoT, a building can now get to know about its occupants. It can provide feedback not only to the resident, but also the facility manager and the owner. So to be a smart building is one that does not just stand there, but one that understands its environment, interacts, learn, and adapts. This was said by CEO of Siemens Smart Infrastructure. So typically connected buildings projects involve facility automation and monitoring for building system. So lighting, elevators, smoke alarms, fire extinguisher, building utilization and security, that is room use, access, surveillance. So these are things will play a major role in the building with IoT areas to provide a smart healthcare, to provide a smart home. Sorry. So for an example, ThyssenKrupp connected elevator solution as its innovation test tower in Rottweil, Germany. The elevator is using Willow Twin, a digitalized virtual model of the physical building, to revolutionize the way buildings are maintained and to enhance the experience of tenant and visitor. So the next thing is we have coming to the final application. There are only few 3% projects that have been identified that are not part of the other 9 categories. So here the industrial cities and healthcare and the traffic rules and the smart home and smart areas, all the things will play a major role with IoT application. And this there are only 3% or the few, and they have been identified that are not part of the 9 categories which we have seen in the previous discussion. And typically IoT platform enabled applications. Here the example IoT platform is in the other area include those in hospitality, enterprise, and finance and support sports. So the example, Cyfex connected exercise equipment. So our customer invest in our catalog of products for our reputation, for developing innovative and reliable equipment and that enhance human performance. So we are furthering that reputation and our customers' success by offering an internet-based monitoring system that helps owners maximize the benefit of our products. So Lisa Juris, the Chief Marketing Officer of Cyfex International. Cyfex International offers premium exercise equipment used in fitness facility worldwide. So the gym owners will only service their treadmill to ensure they stay up and running. So the Cyfex developed a web-based asset management system to provide gym owners with real-time data on the status of each and every treadmill. So these all things will be the best things which with the help of IoT applications. Now IoT is everywhere in each and every domains, in each and every industrial, in each and every aspects. IoT will play a major role. Uh, but the concept will be the same wireless sensor network. So we just moving to the advanced technology with the help of different platforms. In a medical platform, it will pay us an internet of medical things. In vehicle monitoring like a VANET, the advanced time is internet of vehicles. So and right now the IoT will be overtaken with the help of federated learning as well as digital twin. So these two are the emerging research topics right now in the current market. So most probably these two will overtake the IoT. I don't know. Let's see. After 2 to 3 years, we will know about federated learning or digital twins will play a major role other than IoT. So these are things which we have covered. So if you have any questions, you may ask. Okay, thanks for the opportunity provided by Dr. Ajis. Um, if you have any question, you may ask. Sorry, I can't get you. Yes, Professor. I think it's audible now.
Sir, is my voice audible?
Yes, ma'am. Now it's audible.
Thank you, sir. It was really a very informative session, and thank you very much for making us aware of the IoT-enabled projects and applications. And I request participants, if you have any queries, please post it on the comment section in the YouTube.
Yeah.
Till now, we did not get any queries. Let us wait for 1 or 2 minutes before we close the
Yeah,
session.
sure, ma'am. Sure.
Sir, one query from the participant is, which sensors are used in treadmills?
Sorry, ma'am.
Treadmills.
Actually,
Which
in treadmill,
sensors are used in treadmills?
in treadmill, they are monitoring with the help of a motion sensor. So with the help of the motion sensor only, they detect how many steps you have taken. So with the help of the not only motion and each and every sensor is activated over there. Particularly motion sensor is available in treadmill. With the help of that motion sensor only, they can easily calculate how many steps they have taken. That only they have displayed in the monitor over there. Is there any other queries, ma'am?
Sir, can you hear me?
Yes.
Sir, it's a great pleasure for me to thank you for taking a very wonderful session, and this session was very much informative, and it was very helpful to the participants. So in this time, I would like to say something about Dr. Malarvizhi Kumar regarding his research contribution. Actually, Malarvizhi Kumar having more citations. That means Google Scholar citations. His citations are more than 2,500. He started his research career in the year 2018, and within these 4 years of span, he has achieved a lot. His achievement is awesome, and he is having the H index value of around 30. So in this younger stage, this kind of contribution is very much appreciated, and his contribution in the field of research is yeah, highly informative. The field of research is very much motivative for the research scholars who are especially pursuing their research in their younger ages. Again, he has whenever I approached him to take this session, he has immediately accepted my invitation, and without any hesitation, he has given his time and effort, everything for the successful cooperation for the organization of this FDP. So in this time, on behalf of GMRIT management, on behalf of the FDP team, I would like to give my heartfelt thanks to Dr. Malarvizhi Kumar. Again, one more thing I would like to register here. He is very much expert in the fields of Internet of Things, federated learning, machine learning, and health data analytics. So participants can approach him at any time. He will be very helpful in these areas to contribute something, and definitely he will support you in these areas to clarify your doubts. And if you are having any stuck in your research also, you can please contact him. We have already shared his mail ID and everything in the scheduled sheet what you have already got. So once again, on behalf of GMRIT management, I would like to thank you a lot. Thank you, sir.
Thank you, Professor. Thank you a lot, and thanks for the appreciation. And if you have any queries related to the research related to my domain, anybody can easily contact me through the mail. And thanks for the opportunity, and thank you a lot. Thanks.
Thank you very much.